All right, gentle people, we are back. What I want to cover today is the topic quadratic reducible equations. For the people that are watching this that might be doing CSEC at math exams, I've seen a grand total of one question, and that was in 2012, and it involves indices, and so it was a bit of a decision at video recording time as to whether or not to cover this, but I want to kind of do it quickly because it's not one that's in depth. We can cover it today in this video, and I'll set some questions and you should be fine. So let me ensure that my pencil is selected. I think I'm good. Put my doctor right there so I know I can write now. All right, so let me jump into this. And your instructions on something like this might look like solve. That's it. And what's going to happen is that they're going to give you a quadratic of sorts, right? They're going to give you an equation, and you will say to me upon looking at this equation, this is not a quadratic because the highest power of x here is not 2, it is indeed 4, and that's cool, right? And we haven't done any equations to this point where we're solving, I think, for terms that have a power up to 4. I think if we're using roots and we're aware of what the roots are, we could do something, but beyond that, maybe there's something that we can do because it kind of does look like a quadratic in a sense. Now, the very first thing that you want to establish is there a relationship between the power on the term, the second term, in terms of powers of x, decreasing orders? Is this term related to that term? And the very first thing I'd say is that you'll notice that if I square x squared, I will get x to the fourth. And if you're not sure, really x squared is x by x. So if I'm squaring x squared, it is x by x squared, or x by x times x by x, and that happens to be x to the fourth. So without using indices, explicitly having learned how to use indices and how these powers are related, and the relationship when a power is raised to a power, right there, we can still see that the square of x squared gives you x to the fourth. So what we're going to do is we're going to assign this term that can be squared to give us the other power. We're going to assign it a variable. So let me call, here's my little math statement. That's a let, looks like let. Let m be x squared. Now, what's the significance of that to us? Well, if m is x squared, then this expression or this equation here, we had x squared squared, x to the fourth, minus 10 x squared plus 16 is equal to 0. Well, that becomes m squared minus 10m plus 16 equals 0. I know it's in our wheelhouse, right? We've made that substitution there. I know we can get to work. We can do our thing because we're comfortable with our quadratics. We can look at this and we can say, oh, all I have to do is multiply my first term, my term in x squared, my term squared by my constant. And in this case, I get 16m squared. And I'll say, what are the factors of 16? Positive 16. That will sum to give me negative 10. And we've done this before. So we know we can go 16 should be equal to the same thing as negative 8 times negative 2, right? And I can multiply to get a positive 16, but I can sum to get a negative 10. So this is going to be m squared. I can rewrite this minus 8m minus 2m plus 16. Why does that one look like that? Is equal to 0. And we're in business again because now we can simply factorize. What's common to these two? M, what's left? M minus 8. I need to get this bracket back over here. Write it down immediately. We don't think about it. Not necessary. What times m gives me negative 2m? I get negative 2. And you can check. Negative 2 times negative 8 gives me positive 16. We're almost done with this one. We're going to say m minus 8 times m minus 2 is equal to 0. And again, if we're solving the quadratic, we can say, hey, this times this gives me 0. Either this itself is 0 or this itself is 0. Right? Because the only way to get 0 is if one of the terms that you're multiplying by is 0 itself. So if this is 0, we can say m is equal to 8. And if this is 0, we can say m is equal to 2. And you'd say to me, it's done, right? It's done. No, but we never had a term in m before. We had a term in x. And this is just a slight difference that we're going to have, because remember, we said that m is equal to x squared. So at the end here, what we're going to say is what? X squared is equal to 8. This implies x squared is equal to 8, or x squared is equal to 2. And again, a bit of knowledge about how powers work might help. But I'm gonna use the term the inverse operation, right? So if I have squared here and I want to get rid of a square, I'm going to square root. So I'm going to square root the term on this side, and I'm going to square root the term on that side. I'm going to do the same thing here, and I'm going to do the same thing here. And the square root cancels the square, so x is equal to the root of 8, or x is equal to the root of 2. And because it's a square root, and those can either be positive or negative, I'm just going to put a plus or minus here, and a plus or minus here. This should be a plus. In my head, that's what it looks like, right? All right, so it's pretty much done. I would just do one more step if I can, if you'll allow it. And I would say to you, I can simplify root of 8. And again, we're going to get to indices, and we're going to get to roots, surds, and we're going to do this then. But I'll just introduce it now. This would be the same thing as the root of 4 times 2, which is the same thing as the root of 4 times the root of 2, and the root of 4 we know is 2. So this breaks down or simplifies to 2 root 2. So x is either 2 root 2, or x is just plus or minus 2 root 2, or x is plus or minus root 2. All right, light work. And this is how these questions look. All right, we're going to try to knock off 3 of these. And if we can do that, then we're good for today. And we'll pick up tomorrow doing something else. I haven't quite decided which direction we're taking this in. It could be graphs. It could be maybe simultaneous equations as it relates to linear and nonlinear. But we'll cross that bridge when we get there. All right, so let's look at the second question, right? That was the first one. Finding a second one, flipping the page. All right, so the second question, same instruction to solve. And in this instance, we're looking at 3x minus 4 root x plus 1 equals 0. Same premise, it looks a little bit different though. The question is, can you do with this one what you did with the last one? And we started by looking at the term in the middle. In this case, I mean literally in the middle. It doesn't necessarily have to be ordered that way, so you have to be careful. But you can see a relationship possibly if you're comfortable, right? We just did roots and squares, right? So a while ago, just a second ago, we had a term squared and we did the inverse operation, which was to root it, right? Now we have a term rooted, which is root x. And if I square it, one's to assume that since these are inverse operations that we just mentioned, that will just end up with x. We'll talk about this again later when we get into indices, what's happening here and why that is. But for now, we'll just say these are inverse operations. So if I square the root, I get just x. So that means that when I square this, I get this. So essentially what I have is 3 root x squared minus 4 root x plus 1 is equal to 0. Now, I am going to use m. You can use p, you can use r, whatever works for you. I'm just comfortable with consistency. All right, so I'm going to let m equal to the root of x. And if that's the case, then what I have here from the original here, right, becomes 3m squared minus 4m plus 1 is equal to 0. All right, people. Now we're back at a spot where we're comfortable because we can work this out in our sleep, right? Let's get some space. Let's shift this up a bit. All right, I think here is good enough. All right, we're in a good spot. And we'll set ourselves, this is our quadratic. We know what to do. 3m squared times 1 is going to give me 3m squared. What are the factors of 3m squared? That's sum to give me negative 4. Well, this is a positive, so I could use two negatives, right? So I could go negative 3m times negative 1m. So I can rewrite this as 3m squared minus 3m minus 1m plus 1 is equal to 0. And now we're back at that light work phase. What's common to these two right here? 3m, factor it out. What's left? M minus 1. We need this back over here. Write it down immediately. Do not hesitate. All right, what times m gives me negative m? It's negative 1. And negative 1 times negative 1 is positive 1. We're almost there. All right, let me shift some things around here. Got stuff falling over me. All right, let's factor. Factoring out what's common to these two terms, we get m minus 1. And we get 3m minus 1 is equal to 0. This implies that either m minus 1 is 0 or 3m minus 1 is 0, people, right? This means that m is equal to 1 or 3m is equal to 1, which means that m is equal to 1/3. Is that done? No, it's not done. We already know this because we know that m is representing for us root x. So we're going to write that in a second. Let me shift things up as usual. Was it root x? Yeah. All right. So we're right here. I'm putting root x down. So that means that root x is equal to 1 or root x is equal to 1/3. What can I do? Well, we know what to do because guess what? We want to get rid of that root. So what is the inverse of rooting? We're going to square it. We're going to square this term over here. Do the same thing here. Square it. I'm going to square this one over here. And what's left? Why my bracket's looking weird? All right, so I get x here, and that's just 1, because 1 times 1 is 1. All right, you know that. I'm sure nobody made a mistake there. And 1/3 times 1/3 is going to be 1 times 1 and over 3 times 3, which is 1 over 9. And so we're good. We've again solved. All right, I have the dogs. I have things falling, but I know you're still with me. I trust that. All right, so that was question number 2. I have 2 more. I want this to be something that we can one and done. You're comfortable. If you see it again, you beat it up, right? Jamaican parlance. All right, 3rd one. Where are we at? Number 3. More of the same. After a while, the good thing with math is the more you see these questions, the more you go, oh, all right, I see what you're doing there. I got you. I understand the play. All right. Over there now. Plus 10 is equal to 0. All right, light work again. Now you're seeing the relationship because you're looking at that term in the middle and you're going, yeah, I can see that if I square x cubed, I'm going to get x to the 6th. All right, good. All right. And if that's the case, not you necessarily, I would say let m equal x cubed. Whatever your symbol you're going to use is, you can put that there. That's equal to x cubed. That means I have a quadratic because this becomes now m squared minus 7m plus 10. Life with a quadratic and solving. Factors are 10. This looks so familiar. Did we have something like this before? Almost. Kind of. Maybe not. All right. So we end up with factors of 10 that give us negative 7. And its factors are 10m squared. We can use, if it's negative 7, negative 5m times negative 2m. So I can write this as m squared minus 5m minus 2m plus 10 is equal to 0. What's common to these two terms here? Of course, it's going to be m. What's left? M minus 5. Write my bracket back down immediately. Then I'm going to say what times m give me a negative 2m? It's negative 2, and negative 2 times negative 5 is positive 10. What's left is m minus 5. 5 times m minus 2 is equal to 0. And we're in a good place. Yeah, we feel blessed and highly favored. All right, we're almost there. That means that either m minus 5 is 0 or m minus 2 is 0. And that means that either m is 5 or m has a value of 2. But remember that m is what? X cubed. We're almost there. Light work. So let me go back and check. I literally just said it. This is what happens when you get older, people. It's part of life. X cubed. Yeah, so that means that x cubed is equal to 5 and x cubed is equal to 2. All right, what do we do to get rid of x cubed? I am going to find the cube root of x cubed to cancel that. All right, that means I have to find the cube root of 5. And if I find the cube root on this side of x cubed, I have to also find the cube root of 2. And I trust that you are familiar with the cube root of anything. It's similar to the square root, right? In this, you're trying to find a term that multiplies itself 3 times to give you the value. Now, we don't have any one value, simple value that does that. So we're just going to leave the solution as this. Likewise, we're going to leave the solution as a cube root of 2. Yes, there are other roots apart from square root. So again, surds, indices, we'll talk about this at some point in the near future. All right, well, one more, gentle people, and then we're out of here. Or maybe we'll do 2 more, because there is that exam question I spoke about that we can look at. So let's see where this takes us. Give me a second. Let me get us a new page. All right, I think we're good again. All right, the last one that I had slated to do, 1 over x minus 5 times the root of 1 over x plus 6 equals 0. Now I want to say that the process is the same. It is. This one looks a little bit different, but is it though, right? Because all they've done now is they've said, hey, you've seen the questions with the roots. What if we put a fraction within the root? That should mess with your mind, right? But you're bigger than that, right? That can't really trouble you. So if I put the root of 1 over x here, I know that if I square this, I'm just going to get 1 over x. And at that point, it's academic, because now it looks exactly like what we used to. So I'm going to say, okay, let my m equal that value. So let m be the root of 1 over x. And now we're going back to light work, because when I square the root of 1 over x, I get 1 over x. So this becomes m squared. M squared minus what's supposed to be 5m plus a 6 equals 0. Back to quadratic life. We'll have 6m squared. We need factors that give us negative 5. We can use negative 3m and negative 2m. By now, you notice I didn't have to go through that, but we're just going through the motions here, right? Minus 3m minus 2m plus that 6 equals 0. All right. I like it. All right. We're finishing this thing up. Don't beat it up already. You know, I'm going to forget what m is, right? Like in a quick second. All right. But again, that's the age going on. All right. So what's common to these two? M, right? What's left? M minus 3. M minus 3 over here immediately. Ask no questions. What times m gives me negative 2m? Negative 2. Negative 2 times negative 3 is positive 6. We're in business. It's going to be m minus 3 times m minus 2 is equal to 0. That sounds like my garbage truck. Okay. We're rushing this because I'm about to make a lot of noise. So either m minus 3 is 0. There you go. Or m minus 2 is 0, which means that m is equal to 3 or m is equal to 2. Now, do I remember what m is? Watch this, people. M is the root of 1 over x. I want to tell you I remember that, but I have it on a piece of paper. I don't want to lie to you. You know? I'll try not to lie to you today. Maybe another day. Today's what? Tuesday? Maybe on a Wednesday. All right, so what I want to do, I want to get rid of the root. I'm going to square this thing. And then I have to square on this side. And I have to do the same thing here. This was the root. I want to get rid of it. I square it. I'm squaring on that side. What do I have left when I get rid of the square root? By squaring, I get 1 over x is equal to 9. And I get 1 over x is equal to 4. And guess what? It's 1 over x is equal to 9 over 1. 1 over x is equal to 4 over 1. And we have one last step here. I want x over 1 instead of 1 over x. I'm going to invert it. And if I invert the left hand side, I have to invert the right hand side. Likewise, x over 1 is going to be equal to 1 over 4 here. So x is either 1/9 or x is equal to a quarter. All right, people. I really want to do the last, well, the one that I saw in on a 2012 past paper. But that garbage truck is it's one of those. All right, let's see if we can squeeze this in before they blow the horn into oblivion. Last one. This is it. All right, race against time. We're solving 3 to the 2x. Wow, that's what happens when you're rushing. 3 to the 2x minus 9 times 3 to the negative 2x is equal to 8, right? All right. No, this is horrible. I'm writing it over. So that doesn't look like hieroglyphics on this thing. All right, cool. No, the question is, what can we do here? The first thing I'm going to say to you is this. You have to know what a negative power is to kind of work this question out. And I'm extending it to this question because I thought it'd be an interesting one. It looks a little bit different. Essentially, when you have a negative power, it's really saying the inverse or 1 over that term. So it's the same thing as 1 over 3 to the 2x. That's what that negative to the power of negative 2x means, right? So if you're comfortable here, right, what can we do? Well, we could let m be equal to 3 to the 2x. But before that, let's say I don't want a fraction here. Let's do this differently. I don't want the fraction. Let me cancel that fraction. So I'm going to multiply it by 3 to the 2x. Now what happens? This becomes 3 to the 2x squared. This would cancel because this is 1 over 3 to the 2x times 3 to the 2x over 1. And this would be 8 times 3 to the 2x. Now, you notice I haven't said let m equal anything yet because it doesn't look like anything that we properly used to just yet. So in a second, I'll do that. But I could leave this in this form and say that this is 3 to the 2x squared, right? I'm going to carry this over. This was on the right-hand side, so I'll have to subtract it on the right-hand side and then subtract on the left-hand side for balance. When I subtract it on the right-hand side, it cancels, but then it stays over here on the left-hand side as a negative term. Minus 9 is equal to 0, right? Now, if this is the layout, I can let m equal 3 to the 2x, at which point I have something squared. I have m squared minus 8m minus 9 is equal to 0. So this one is a little bit different. And it took us a second to get to where we need to be, all right? But we're there now. And we're going to say, okay, what are the factors of negative 9 that sum to give us negative 8? Well, it's a negative term, so one is negative, one is positive. I can say minus 9m plus m minus 9 is equal to 0. What's common here is m. What's left is m minus 9. Write that down immediately. What multiplies m to give me m? It's just going to be 1. And I'll have m minus 9 when I factor times m plus 1 is equal to 0, which means either m minus 9 is 0 or m plus 1 is 0. All right? We should be there. We're almost there. Which means m is equal to 9 or m is equal to negative 1. Now, if m is 3 to the 2x, that means 3 to the 2x is equal to 9 or 3 to the 2x is equal to negative 1. And one of the things that you must know is that you can never raise a positive term to any power and get a negative term. So there is no solution on this side. This doesn't give you a solution. That's out it. But over here, we can say 3 to the 2x is equal to 9 or 3 to the 2x is equal to 3 squared. And if the left side is equal to the right side and the bases are the same, that means that these two must be the same. So I can say 2x is equal to 2, which means x is equal to 1. And that is our solution. Thank you for bearing with me through the noise. I'm going to ask you not to remember to like and subscribe. I'm going to actually post probably a worksheet on this. It is a bit of a one and done, but we will see questions like this as we go through in the season, as we move forward. Not as any formalized topic, reducible quadratic equations, but I wanted to cover it in good conscience. So I'm going to send this your way. And again, don't forget to like and subscribe. And we'll keep doing some work here. Hopefully, you can be ready for your exams by the time they come around. Have a great one.